The Royal Swedish Academy of Sciences has decided to award the 2016 Nobel Prize in Physics with one half to David J. Thouless and the other half to F. Duncan Haldane and J. Michael Kosterlitz for theoretical discoveries of topological phase transitions and topological phases of matter. The chairman of the Nobel Committee will provide some introductory remarks on the Nobel Prize in Physics. Nils, please.
I take this thing, you see, I can bend it a little bit, compress it, but in order to make it to change number of holes, I have to do something drastic. I have to break it apart. And this stability of the topological invariance is going to be important. Sort of unexpected, because in these experiments, laureates showed that you could do the same without another kind of system, a set of magnetic atoms in a chain. And he could show that even in this case, you had such an exotic topological.
Like most discoveries, you stumble onto them and you just have to realize there's something very interesting there, and one never realizes the full implications of these things until other people have started thinking it through and one realizes the big picture. So most of big discoveries are really that way. I think you, at least in theoretical things, you never kind of set out to discover something new. You stumble on it, and you have the luck to recognize what you found is something very interesting.
Thank you very much for your interest, and welcome back tomorrow for the Chemistry Prize. Thank you.
That's an example. This is a theory prize. Of course, people like to understand physics in terms of applications, but in fact, this is a case where the theoreticians had very abstract ideas, which at the time they didn't think would be useful at all. But now we're seeing in the experimental physics world lots of experiments coming out, lots of new materials being generated, which have where we use this topological description to describe what we measure. In the world of modern physics, we experiment with things at very low temperatures and in very what we call lower dimensions, so very thin layers, very long straight lines, thin narrow lines of material. And in these small, what we call low dimensional systems at low temperatures, very strange things happen. They begin to conduct electricity in bizarre ways. And this has led to important applications that are emerging and some which are actually used today.